So in today's lecture, we are going to start with a revision on hybridization before we go into nomenclature. So I hope you guys did your research on how to name basic alkanes, alkynes, and alkyl groups. Yeah. So we'll start with hybridization. So hybridization, like we said last time, this is a state in which the carbon atom orients itself. So we talked about hybridization à l'état sp3, and we say that this leads to the formation of simple bonds, which are, is it sigma or pi bonds for sp3? Is it sigma or pi? Which one is it?
Sigma bond.
Exactly, it forms sigma bonds for sp3 hybridization. And we gave an example of methane with is it tetrahedric structure with an angle between the adjacent hydrogen atoms to be 109.5 degrees. Yeah. So we also looked at hybridization à l'état sp3, and we said that at this state we have the carbon atom forming a double liaison. So now here the question is, what are the makeups of this double liaison? Is it pi pi or bien sigma sigma or bien sigma p? Which one is it?
It's one sigma pi, one sigma bond and y pi bond.
Exactly. So it's one sigma bond and one pi bond. Please take note, every time we are looking at any simple liaison, we are talking about a sigma bond. But when we're now looking at a double liaison, it's the sigma bond that comes first, then we have an overlap over the pi bond. Now we have the last one, which is sp hybridization. So now here we have what you call the formation. Oh, before I forget, then double liaison has a structure triagonal with an angle between the adjacent hydrogen atoms that is for ethane 120 degrees. Then we have the last one, which is sp hybridization with a triple liaison. Now here, what is the bond orientation? Is it p p p p sigma sigma ou bien sigma sigma p?
It's one pi bond and two. Oh, it's one sigma bond with two pi bonds.
Exactly. So it's one sigma bond and two pi bonds. Yeah. So that is it with hybridization, and it forms a linear plane with an angle between the adjacent hydrogen atoms to be 180 degrees. So are there any questions on hybridization before we go into nomenclature? Okay, so assume there are no questions. So we continue. So you see, in organic chemistry.
I have a question. If you can just kindly send those, I don't know if you sent already the book for where the angles at which they
actually
bond.
send them. Okay, I'll just highlight the book that I sent with the angles and Shanshan. I gave a resume there. I think I already sent it in the group. I'll resend it. Yeah. Any other question, or everything is okay? We can continue. So hybridization is basically the build-up for everything we're going to be doing in organic chemistry. It forms the basis of all organic compounds. Talk about compounds like benzene, talk about compounds like naphthalene, talk about compounds like ethyl propanoate, talk about compounds like okay, that's all. Yeah, talk about those types of compounds. It is because of the double liaison, single liaison, triple liaison, that we have the formation of these compounds. It's because the carbon compound has the ability of forming hybrids in different states, depending on which atom it is supposed to form a liaison with. So when carbon is bonded to hydrogen, it can either form a single liaison. It can also form a triple liaison with some exceptions. When you look at SN reaction mechanisms, you understand that at some point the carbon atom can also sustain 5 bonds. Yeah, but the idea is the hybridization here is the backbone of all compounds we are going to study in organic chemistry. Be it nomenclature. Nomenclature will be just naming the compounds. Later on, we're going to understand their stereo chemistry, how isomers are arranged in 3 dimensions. So, without wasting of time, we are going to look at, for today, we are going to study the rules of nomenclature in organic chemistry. So, if I may ask, which organization is responsible for naming organic compounds or just giving names to compounds? If you guys know, please state. If you don't know, please state.
I think it's the IUPAC.
Exactly. So it is the international. I think you guys have done your research, please. So it is called the International Union of Pure and Applied Chemistry. They are responsible for the nomenclature of all molecules that we are going to study. So we are going to study these molecules selon IUPAC. Then today, I hope, inshallah, I hope we are going to finish with these ones, these 3, Alcanes, Alcènes, and Alcyles. So this is a SP3, hybridization, SP2, SP. So we are going to look at the 3. The nomenclature is the same, but with a few additions, because the build-up is a simple liaison. Then from there on, we are going to build up. There will be no TD. Attention, there will be no TD for nomenclature, because the polycop I'm going to be using already has examples. I'm using my polycop for school. Already has examples. So we'll be going through the examples together. If you have a question, please tell me that I don't understand where this thing is coming from, so that we go together. But for stereochemistry, there will be a TD. So for nomenclature, there will be no TD, but examples, a lot of examples, plenty of examples. So just follow through. If you have a question, please let me know. Then before we go any further, Mr. Samuel always wants a name before we start the class. So when someone asks you for IUPAC name, the compound, you know the rules, and so do I. So at the end of the lecture, you guys are supposed to at least understand the fundamental rules that you're going to be using for any compound, because starting from alkanes to carboxylic acids, it's the same principle that we are going to be applying, but it's just going to be a build-up and addition on certain things. So for example, I tell you to name octane with 8 carbon atoms. So if I add the function, it becomes an acid. For example, if it's a carboxylic acid, it becomes a carboxylic acid of that chain. So it becomes octa. For example, if it is 18 carbon atoms, it becomes octadecanoic acid for those that are going to be doing biochemistry. Yeah. So it's the same principle. The fundamental, the basic chain is what you use to build other molecules. So if you get how you name alkanes, then definitely everything in organic chemistry is going to be simple when it comes to nomenclature. Everything will be easy when it comes to nomenclature. So without wasting much of your time, we go to the polycopy that has this cool. Voilà. So, is it clear? Is it visible? Please take it.
No.
It's visible now.
It's visible.
It's visible now.
Alhamdulillah, alhamdulillah. So, Règles de nomenclature on Chimie Organique. So, for the first part, I'll be a bit slow because it's a build-up for the second. So, the International Union of Pure and Applied Chemistry is basically the organization that is responsible for the nomenclature of all compounds. Now, because we are looking at organic compounds, so we are going to narrow it down to all organic compounds. So the International Union of Pure and Applied Chemistry gives these compounds what you call nom usual and nom IUPAC. So nom usual is the normal name, like a nickname we give to certain compounds. Then selon IUPAC, we follow the number of carbon atoms that each have. Like there is a specific suffix for a specific number of carbon atoms that a compound has. So if the number of atoms that a compound has is equals to 2, every time you have that compound, the nomenclature will be eth something, either ethanoic acid, it will be ethane, 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 it depends. For as long as it has 2 carbon atoms, it will have that, no, not suffix, sorry, prefix. It will have that prefix. So here I have 3 examples. That is acetic acid, which is also known as ethanoic acid, selon IUPAC. We have acetone, which is also known as propane. It is, those that have studied organic chemistry, I know there are people that have studied organic chemistry at another level. So what group or what function is acetone? What function is acetone? Is it an aldehyde or bien it's a cetone? Is it an aldehyde or it's a cetone?
Cetone.
It's a cetone. So even the name here, acetone. So a cetone has a terminaison of ONE. So this is just an example. So we have acetone. Then the nom usual is acetone. Nom IUPAC is propanone. It's a propanone. Then we have glycol, which is a diol. A diol is an alcohol with 2 alcohol functions. It's an alcohol with 2 functions. A diol. There are 2. The di here simply shows that there are 2 hydroxyl functions. So whenever we're going to start looking at nomenclature, we are going to first consider a suffix of a compound. Then later on, we are going to add a prefix for a particular compound. So that is the basic nomenclature we are going to do. The basic for alkanes, the first thing you're supposed to do is know what the prefix is. Then after naming the prefix, then you add a suffix. So the example that we have here is what we are going to be doing at all times. So given, for example, a carbon chain, that carbon chain has got, say, 3 carbon atoms. So for any compound, like I said, for any compound in organic chemistry with 3 carbon atoms has got a specific prefix we are supposed to use. So the prefix for 3 carbon atoms is pro something. So propane, propanone, prop anything. So the prefix is prop. Then the number of carbon atoms also defines what the prefix is going to be. So all in all, what we could say is the prefix and the chain principale are ensemble. They are one and the same thing. It is because the chain principale is what defines the prefix. But the suffix changes because we have approximately, 10 functions. We have got the carboxylic acids, we have the esters, we have the nitriles, we have the aldehydes, the cetones, the alcohols, the thiols, the amines, the ethers, a lot of them. So it is the suffix that plays an important role when it comes to nomenclature. Any questions so far? So I'll repeat. So we are saying whenever we are naming a compound, there are 3 parts we are supposed to consider. There's what you call la chaîne principale, suffix, na prefix. So we are saying the chain principale and the prefix are one and the same things. Now the question is why? It is because the chain principale defines the prefix. So like I said, in organic chemistry, a specific prefix specifies the number of carbon atoms that compound has. We're going to look at, there's a table I have for you. It goes up to, I think, 20 prefixes we're going to look at, but I won't go as far as 20 in the examples. So the prefix basically defines the chain principale for a compound. But now what defines the compound is the suffix. The suffix is what defines the compound. Take it like I said they are carboxylic acids, they are anhydrides, they are amides, they are amino acids, they are alcohols, they are acetones, they are thiols, they are amines, they are ethers, etc. There are a lot of them. They are phenols, they are benzene molecules. There are a lot of molecules that are there. All they come from one thing, and that thing is called a suffix. The number of carbon atoms, you shouldn't worry, because each one has got a specific name for a specific chain principale. Any questions so far? Okay, continue. So, like I said last time, we're going to study purely carbon atoms. We're going to study the first ones, which are non-cyclic. So this is the class of aliphatic. I told you guys we're going to look at aliphatic and a bit of, though I'm not supposed to do it, but a bit of aromatic for you guys to understand how we name compounds like benzene, maybe vanillin, all those compounds. So today's first part will be hydrocarbons, hydrocarbules, non-cyclic. So we're going to look at only straight chains compounds that are open, like it says here, un hydrocarbure acyclique est un composé dont la chaîne principale est une chaîne ouverte d'atomes de carbone. So it's basically open chains of carbon compounds. Then the first one, the first class, like I said, was going to be alkanes with a single liaison. That is the simplest liaison. We said this is sp3 hybridization. Then hydrogen, the hydrogen to carbon bond is a simple bond, and that bond is called a sigma bond. So for these alkanes that we have learned so far, even Kuzed, we learned about this. We said that the general formula for any alkane will be CN H2N plus 2. For any given number of carbon atoms, we can also define how the formula brute in English is empirical formula, what it can also signify. So basically, the principle here is just counting the number of carbon atoms you have, then we add the prefix. You just count the number of carbon atoms you have, then you add the prefix. So first example, we have this chain here. Now, what type of representation is this? Is it zigzag topologique, ou bien semi-développé, ou bien forme développée pleine, ou bien forme compact? Please, responses so that we follow, we go as fast as possible. What kind of representation is this? Is it forme développée pleine? Is it forme semi-développée, compact, ou bien topologique, zigzag? Which one is it?
Topologique.
Topologique, also known as zigzag. So we are just going to count the number of carbon atoms. We just count the number of carbon atoms. Then you see how it comes about. So we say this is 1, 2, 3, 4, 5, 6. So we can start from this side. 1, 2, 3, 4, 5, 6. So for any open chain, because like it says here, we are going to be looking at chain ouvert. For any open chain, you can start from whenever position. You can either start from this side, go into this direction, or this direction, go into the other direction. It only becomes tricky when you have a substituent. It only becomes tricky where you're supposed to start from when you have a substituent. So for now, because we have not started doing substituents, we're going to start with the basic one, which is this one, with 6 carbon atoms. So the suffix for, the prefix for a 6-chained alkane is what? Is it hexa or hepta? Hexa. So hexa is the suffix, or the prefix, sorry, the prefix. Now, we know that the function group we are talking about now is alkane. So this is the formula. We have the prefix, we have the chaîne principale, we have the suffix. So now we are saying the chaîne. Muta, network is cutting again.
No, I don't know what that is. I think it's from someone else.
Okay. So we are saying
I have a question. Before we move on, sorry for taking you.
I can't get you. I can't get you.
Can you get me now?
Yeah, a bit.
Yes, I'm saying before we move on, I have a question on the other page. Just scroll down a bit for me.
Is it this page?
Again? No, the other one.
The first one. This is the first one.
Yes, this same. Yes. I did get your point on des alcanes ramifiés.
Ramifié.
Not? Yes.
No, I've not come to the alkanes ramifié. Alkanes ramifié for now, no. We're going to get to that one later, because ramifié now, this is where you have a substituents. Il existe alkane linéaire et alkane ramifié. Yeah, that's a good point. Yeah. So the first part is linéaire. Then later on, we're going to look at ramifié. So we are saying the formula for nomenclature of the simplest alkane chaîne ouvert, open, is the prefix. Then we are going to add the suffix, because we understand to say the chaîne principale is also a dependent factor on the prefix. Any questions so far? Any questions before we continue? Okay, there are no questions. So for this one, we are saying the formula is prefix, chaîne principale, suffix. So, c'est-à-dire, how many carbon atoms we have here? We have 6. And we are saying the prefix is 6. What's a prefix for 6? In organic chemistry, we said it's hex. Now, that also defines the chain principale. Now, the chain principale here also has 6 carbon atoms. So, we are going to say hex. Now, what's the suffix? The suffix is dependent on the function. The function of the group is what now determines the suffix. Now, here we are talking about alkanes, and these alkanes are linear. Attention, alkanes are linear. So, it's going to be hexane. So, with 6 carbon atoms. Let's hope this one is clear. Is it clear? Okay, I'll take it it's clear. I take it it's clear. So then we also have another one here. Alkane is the question. Alkane.
Oh, we move.
Okay.
Yes.
Please ask as many questions as possible.
So before we. Okay. For hexane, what's the chain principale there?
The chain?
The chain principale.
No, the chain principale is this same one. Carbon. It's just that the form here that we've used is what you call, like you guys said, it's la forme topologique. So the form topologique or bien zigzag is written like this. It can also be written as carbon, carbon to my straight lines, like carbon, 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 carbon. So the chain principale is the longest continuous chain. It's this one. 1, 2, 3, 4, 5, 6. It's the longest continuous chain. So we can have la forme topologique, la forme semi-développée, la forme compacte, ou bien la forme développée pleine. So now it's just that with this representation that we've given, zigzag, the number of carbon atoms goes up, come down, up, down, up, down. La forme topologique, ou bien la forme zigzag. So la chaîne principale is this same one. But la chaîne principale, is it clear for this one? For alkanes linear. Linear, is it clear? If it's clear, please. You say it's clear, we continue.
Yes, it,
Okay. So now, okay. So now we have another chain now. Now the chain here has got one hydrogen or one carbon atom less, and this carbon compound is 1, 2, 3, 4, 5. Theta D. The suffix is going to be another defining factor of the chain principale. So in other words, what I'm trying to say, please take note. The chain principale and the suffix are one and the same thing. Oh, prefix. The chain principale and the prefix are one and the same thing. What defines a compound is the suffix. The suffix can either be an alcohol, an amine, an amide, carboxylic acid, an ester, etc. But what defines the chain principale and the prefix, they are one and the same. It's one and the same thing. The number of carbon atoms that you're going to have define the chain principale. It also defines the name of the prefix. So like I said, for 2 carbon atoms, you've got what you call ethane. For 3, you have quelque chose, the propane, propanoate, propano. I don't want to go in detail with my theory, but for now, that's how it goes. That's how it flows. Is it clear for alkanes linear? Alkanes linear.
Yes.
Now we go to alkanes ramifié. What it means to be ramifié is branched alkanes. Branched alkanes. Now, branched alkanes, how do we do our nomenclature? When we are naming a ramifié compound, we look, the first rule number 1 is cherche pour la chaîne principale. La chaîne principale is the one that contains the highest number of carbon atoms. Please take note. This is rule number 1. There are rules, they will be coming one by one. So. Rule number 1. You count la chaîne principale, the one with the longest or bien the most high carbon atoms. So in this case, we'll start with this one. So the number of carbon atoms that we have in this case, we have 1, 2, 3, 4. 1, 2, 3, 4. We have in this direction, we have 1, 2, 3, 4. Then we also have 1, 2, 3, 4. You guys be answering, right?
Yes.
Amen.
So there are 1, 2, 3, 4, and you also have 1, 2, 3. So when you're naming such a compound, so you see here what they've done is they've counted the number of carbon atoms that are there and have applied this formula. Now, when we are talking about nomenclature, when you're talking about nomenclature, you are supposed to look for the longest continuous chain. Then you are also supposed to look at what radical alkyl formula you have. So here, okay, I've already gone a little bit ahead of you, but it's still worth it. So for a compound like this one, even though it has got, because what they are doing here is just counting the number of carbon atoms and naming the compound. Now we can also attack it with nomenclature right now. So we are going to say this compound here, okay, it contains 5 carbon atoms, which is true because we count here 1, 2, 3, 4. There's also another one here, 5. Or maybe we say 1, 2, 3, 4. There's another one here, 5. Which is true that it satisfies the general formula of an alkane, which is CnH2n plus 2, this one here. Now, if we were to attack it now with nomenclature, we are saying when you are naming an alkane ramifié, we are going to look for la chaîne principale. La chaîne principale, also known as, aka, the chain with the highest number of carbon atoms is going to be la chaîne principale. Rule number 2, you are going to look for where the substituent is also what you are calling a radical alkyl. So a radical alkyl is an alkane with one hydrogen atom less, which you can see from this formula here. You have CN H2N plus 1. In other words, we are saying one hydrogen atom less. So it's going to be HCH H2N plus 2 minus 1. So this gives this formula. So another recap. We are saying for you to name an organic compound that is ramifié, rule number 1, you look for la chaîne principale. La chaîne principale, also known as the chain containing the highest number of carbon atoms, is also known as la chaîne principale. So in this case, we don't just go and say this is the longest chain. No, we count. We say, okay, we're going to count. Which one is the longest chain? We start from all positions, right? You start from 1, 2, 3, 4. Okay, you say there are 4 this side. Okay, you start from this side. Like 1, 2, 3, 4. Okay, there are 4 this side. You start from top. Say 1, 2, 3. 1, 2, 3, 4. There are also 4 this side. Come from upper. Say 1, 2, 3. So there are actually like 4 ways we can count. The first one is 1, 2, 3. The second one is 1, 2, 3, 4. The third one is 1, 2, 3, 4, which is also the same as going like this. Now, we're saying principle number 1 is looking for la chaîne principale. So in this case, la chaîne principale will be this one here with 4 carbon atoms. 1, 2, 3, 4. With 1, 2, 3, 4. 4 carbon atoms. Now, some of you might ask me this question. That is so. Why didn't you go like this? It's the same thing, yeah. 1, 2, 3, 4. It's still the same thing. Because when we name this compound, you find out that because of this position here, because of this carbon that's here, the name will still be the same. So now we are saying rule number 1 is knowing la chaîne principale. So we know in this case, la chaîne principale peut être this one, 1, 2, 3, 4, ou bien 1, 2, 3, 4. Any of these, not this one. Not this one. Why? Because the number of carbon atoms here, 1, 2, 3, is less than the number of carbon atoms in this chain. So please take note. When you are naming an organic compound with la chaîne ramifiée, you start by counting the number of carbon atoms in the chain that is principal. The chain that is principal will always have the highest number of carbon atoms. It will always have the highest number of carbon atoms. Later on, when you find the chain principal, you now look for if it is having a radical. So we're saying a radical is an alkane with one hydrogen atom less. So take for instance, like we are saying, a radical is an alkane. Now we are removing one hydrogen atom from that alkane. We're going to have ethane with 2 carbon atoms. We remove one hydrogen. It's no longer going to become ethane. It's going to become ethyl with a suffix L. This one, where is it? With where is it? I just want you guys to look at the suffix. The suffix is YLE. The suffix is YLE. So for a compound that is with 2 carbon atoms is called ethane. That is with alkanes. We're not going to alkenes with double liaison. We are still on single liaison sample. So we are saying an alkane with 2 carbon atoms is called ethane. So if we remove one hydrogen atom, it now becomes an alkyl. Alkyl. So what happened is alkane is spelled as A-L-K-A-N-E. Now we remove the suffix A-N-E and replace it with Y-L-E. So in this case, now the suffix that we are going to include for this radical here, because this is only one carbon atom, and one carbon atom from this table here, we have methane, ethane, propane, butane, penta, hexa, hepta, octa, nona, deca, unideca, all those. We remove the suffix ane and replace it with yle. So this is methane. Normally, we're supposed to have a methane group here. Now we are going to have a methane minus one hydrogen atom, which is now going to be called a radical of methane. So instead of it being called methane, it will be called methyl. Methyl. Now, rule number three. Rule number three is we are supposed to look at which one is the shortest. What we used to do for our organic chemistry is, this is what we used to think of it to be. The question is, we are going to ask this question in our heads. Which of these routes is the easiest? For example, we say this is carry 4, and there are two routes. There is this route from this side on the left, on my left, and there is this one here on my right. Now the question is, which one is the easiest or the shortest route to move from this side? Now you want to come here. You want to come to this point. This is where carry 4 is. Now you're moving from this side and from this point. Which one is the simplest route, the easiest route to use? It's definitely this one here on my left. Why? Because this is just 1, 2. That's like one step to this point. And this other side, this is 1, 2, 3. This is 3.3 steps for you to come to this point. So automatically, when we are naming this compound, we start with the carbon that is closest to the substituent. So I'll repeat. The first rule is we are supposed to determine la chaîne principale. La chaîne principale is also known as the chain that contains the highest carbon atoms. The highest carbon atoms is called la chaîne principale. Tawanga had asked me a question, say, what is la chaîne principale for the first one? So la chaîne principale for the first one was 1, 2, 3, 4, 5, 6 carbon atoms. Why? Because it is the total number of carbon atoms that this compound has. Like when you count the number of carbon atoms that this compound has is 6, and it is the only chain that is open over here. We said it's open and is linear. There is no substituent. Now, she asked me another question, say, so we've not talked about alkanes ramifié. Now we come to alkanes ramifié. Now, when it comes to the nomenclature of alkanes ramifié, we still apply the same principle for alkanes linear, but in this case, we add in 2 more rules. The first one being looking at the chaîne principale, the one that contains the highest carbon atoms. The highest carbon atoms will always be la chaîne principale. You are supposed to count every time you're naming a compound. You are supposed to count how many carbon atoms do I have in this organic compound. Later on, you are going to go to rule number 2. So rule number 2 states that you are supposed to now look at the compound and look at it to see if the compound contains any substituents. So we are saying a substituent is an alkyl radical, that is an alkane with 1 hydrogen atom less. It is an alkane with 1 hydrogen atom less. So I said the formula can also be written as CnH2n plus 2 minus 1. Why? Because it is an alkane with 1 hydrogen atom less. So that is the radical we are going to look at. Then the third rule. The third rule is we are supposed to look at which one is the shortest route. So I gave an example of carry 4. Now carry 4 in two directions. There's one moving from the left and one moving from the right. So this is our carry 4, or maybe say episide. There's one moving from the back gate, or no, let's use carry 4. There's one moving from the left-hand side, my left-hand side, and the other one is moving on my right-hand side. Now, we are saying the shortest is where you start from counting, because some of you start asking me, how do you count? How do you know the position of? So this is how you do it. You look at the chain principal and you look at which one is the shortest route possible to the substituent. In this case, the shortest route possible to the substituent is this route. Why? Because when you count the number of carbon atoms here to this position, you only have 1 carbon atom. to this position to make it 2. So this is going to be 1, 2. Now, when you go on the other side, you find that it's going to be 1, 2, 3. Then someone among us you ask me a question. Okay, Jerry, so take for instance, instead of us counting from this position, why aren't we counting from this? It's still the same thing. Even if we count from this position, 1, 2, and 1, 2, 3, this part will still be the shortest distance possible for this substituent. Now, we are saying the substituent gets a name of the alkane, and you just replace the suffix with il, which is YLE. Now, in this case, the suffix is methyl. So we are saying the chain principale is 1, 2, 3, 4. So what is the suffix or the prefix for 4 carbon atoms? So we go back to the formula. The formula is we are supposed to look at the prefix, and the prefix defines what la chaîne principale is. Then later on, we are going to add the suffix. So in this case, what it is that we are going to have 1, 2, 3, 4, which is la chaîne principale. And we are saying 4 carbon atoms has a prefix called, therefore, buta. It's called buta. So with BUTA. So that is our chain principal prefix. Now, what function group are we looking at? We are looking at alkanes. So automatically the name is going to be butane. It's going to be butane. But now there's another thing we're supposed to take into consideration, because rule number 1 is naming la chaîne principale. So now chaîne principale is called butane, comma. Butane has got how many carbon atoms? 1, 2, 3, 4. It has got 4 carbon atoms. So in this case, we are saying the prefix for 4 carbon atoms is buta. Now the suffix is butane. Sorry, buta, that's the prefix. And the suffix is ane, which is going to make butane. Butane. So not butane, but butane. Butane. So now we are saying we are also supposed to look at what substituent that the compound has. In this case, we have a compound that is butane with a substituent on carbon number 2. Now, how do we find carbon number 2? Now, this is where I explained about the carry 4 thing. So from this position to this position, we find out that the position of the alkyl group is at position number 2. So we always consider the lowest number as possible, or bien the shortest route possible. So in this case, we're going to move from 1 to position 2. This is the simplest route we can go. So make sure when you're counting the number of carbon atoms, you use the simplest, this is the simplest explanation I can give. The simplest route you can use to get to that position is going to be your index, or bien the number at which the alkyl group is positioned at. So in this case, we have 1, 2, and we also have 1, 2, 3. So automatically, position number 2 is the one with the lowest index and is the shortest, or maybe let me say shortcut. It is the shortcut to this alkyl. Now, so when you're looking at now nomenclature, the formula now changes for the ones at ramifié. The ones that are ramifié now, it no longer becomes the chaîne principale and you put the suffix at the end. No, it now becomes the prefix, yes, la chaîne principale, and the suffix. But now, before naming this whole compound, this now becomes, when you have a chain and it is ramifié, this whole thing becomes like a surname. This whole thing becomes like a surname. Then the position of the substituent and the name of that substituent become like the first name. So whenever you're writing names, you always write your first name. Yeah, but there's some exceptions. Sometimes we write our nom, then write our prenom later. But here in organic chemistry, we write our first names, then our last names come at the end. So in this case, the substituent's position and the substituent's name become the first names, then the prefix chaîne principale and the suffix become the last name. Now, in this case, we have la chaîne principale, which is 4 carbon atoms, is known as butane. And we are saying at position number 2, we have an alkyl. Now, what's the name of this alkyl? We are saying one carbon atom is called methane. Now, methane minus one hydrogen atom becomes CH3. And CH3 is called methyl. So this is the one with one carbon atom. So one carbon atom. Now, normalement, the name of the chain principale for one carbon atom is called methane. But now, because it appears to be an alkyl group in this case, it now becomes a methyl instead of methane, but becomes methyl. So when we're naming this one, we are going to start counting from this position. Why? Because we are saying this is the shortest route possible to get to our substituent. So it is on position number 1, number 2. So this is position number 2 for this alkyl group. So position number 2 is where the alkyl group is located. It's going to be 2. The formula is going to be 2 dash, which is a tire, or dash. It's going to be 2 dash methyl. Then la chaîne principale. It is going to be position number 2. Then la chaîne principale with its suffix at the end. So I'll change my presentation. I'll just show you how we write the name for this compound. So far, are there any questions before we forge ahead to other compounds that are ramified?
I have a question. Why is it that it's under the same thing? I've gotten your explanation about that, but I don't understand why it's C5H12. That
Nice.
you're talking about.
Nice question.
And
Nice
now came.
So I said, dang. Can you guys see my sharing? The PDF. Can you see it? Can you see it?
Yes.
So the explanation I gave here, what basically they're looking at here is the examples of alkynes linear and alkanes ramified. Then we are also just looking at how many carbon atoms we have. Then I also said, now, because like this is how the core is divided, you're supposed to now understand what alkanes ramified and alkanes linear are. Then later on, look at how many carbon atoms make up a certain compound. Then later on, start naming alkyls and how the hydrogen atom -1 thingy comes about. Then start naming compounds. So what I've done is, because look at the example that they've put here. If I start with this example, to be a bit complicated for you guys. So I started with this one to just show you how we name the simplest. This is the simplest compound you have. So now the question you're asking me is, why is it that we are counting 4 carbon atoms in this line and we are forgetting this one? My answer is, in this part of this core, the first part here, we are just looking at alkanes that are ramified and alkanes that are linear. Now, we're just counting the number of carbon atoms and we are just simply obeying this formula here. The formula here is CnH2n+2. We're just counting like, okay, how many carbon atoms does this compound have? Now, we are saying there are those that are linear and those that are ramified. So the ones that are linear, they are written like this: 1, 2, 3, 4, 5. And the ones that are ramified, note, we are looking at the number of carbon atoms here. We are looking at the total number of carbon atoms, then we use this formula. By the way, this compound here, even though we are calling it 2-methyl butane, it can also be called pentane. Now, we don't want to go in detail because it can also be called pentane because the 2-methyl butane will be called an isomer of this compound. So for now, we're looking at isomers, we're looking at nomenclature. So here what they're trying to say or trying to explain is basically that we are looking at the number of carbon atoms that are going to satisfy this general formula here. There's nothing more to this. Then I just added the part for nomenclature to just show you how you can name this compound, because the first example in this coup will be something like this. Now, if I start with something like this, when there's something very simple here, it will be a bit tricky for you guys to get where I am coming from. So, is it clear here? So we are basically just counting the number of carbon atoms, that's all. Then I added on to say, okay, let's name this compound using the IUPAC nomenclature with these 3 rules. The first one being looking at the chain principale. The second one is looking at which one is the la chaîne substituent. The third one, which is looking at which one is the first one, which is looking at the chain principale. The second one is what's this? Looking at the alkyl group. Then the last one is now determining the position at which the alkyl group is found at. Then later on, you add in your suffix. Then the name becomes you note the name. So I want to share the screen on the PowerPoint to show you how we name this compound, like how you write it. We are saying in organic chemistry, we are going to start with la chaîne. We're going to start with what do you call it? We're going to start with the first name. Later on, go to the last name. Normalement, sometimes people interchange. Some start with their last names. Some will start with their first names. But la même chose. I'm just giving it parenthesis where you guys should take note that in organic chemistry, we are going to start with the first name, which is going to be the position of the alkyl group, and the last name will be the prefix, la chaîne principale, and the suffix. Is it clear? Is it clear?
Yes.
Alhamdulillah, alhamdulillah, alhamdulillah. Any questions? Please, if there are any questions, please. I want to hear.
Sorry, I had a network problem, so I couldn't get the explanation to her question.
Okay. No, okay. Don't worry, boss. Don't worry. We are going to explain Tionsiap. So let me just write the name. 2-methyl. So we're saying it has got 4 carbon atoms. So you're saying but. This is for 4, and the suffix is N. So which will be, if you write it properly, to be 2-methyl butane. Not butane, butane. This is what we're looking at. So the formula is, just a minute. The formula is, we're going to have first name, followed by last name. This is what we're going to do, the standard. So we are saying chain. Okay, so these are the rules, eh? So we're saying whenever you are naming a compound that is ramifié, please take note. If it's ramifié, the first thing you're supposed to take note is the first name will be the substituent. Then the last name, it will be la chaîne principale with its suffix and shinganan. So we are saying the first thing is you're looking for your chaîne principale. The chaîne principale in this case will be the one consisting of the highest number of carbon atoms. In this case, we can start from this side to be 1, 2, 3, 4, or bien 1, 2, 3, 4, 1, 2, 3, 4, or bien 1, 2, 3, 4. But the position of the substituent determines where we start from. This is where I came up with the example of carry 4. You can start from anywhere when you're looking for the chaîne principale. When you're looking for la chaîne principale, let me just do another diagram here to just give you an insight of what I'm talking about. So this is the first one, the second one be like that. We see one there. Okay. So we're killing one bird with 5 stones. So what I'm trying to say here is you can start from wherever. For a chain that is linear, you can start from this side. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. C'est la même chose. Now, it changes because we are looking at the shortest possible distance we could take for us to reach the position of the substituent. Now, in this case, we have this one here. La chaîne principale is 1, 2, 3, 4, 5. Now, the question will be, which one is the shortest route? Moving from this side, 1, 2, 3, or bien 1, 2, 3. Now, we find that both positions are the same. So we can move from this side to this side, or bien from this side to this side. C'est la même chose because the position will still remain 1, 2, 3, position number 3, or bien 1, 2, 3, position number 3. It remains the same. But when the number of carbon atoms on both ends are not the same, like this one, the example we have here, like this one, instead of you counting from 1, 2, 3, 4, this side, starting from this side, we are going to start from this one because it is the shortest possible route for us to reach our substituent. Now, in this case, our substituent is a methyl group. So it being a methyl group, we are going to say, okay, the nomenclature, the name, how we do it here, we start with the first name, and the first name is always la substituent and its position. This two shows the position. This two shows the position, sorry. This two here shows the position. It shows the position at which the substituent is found at. So we are saying for this molecule here, we have a substituent at position number 2. At position number 2, this substituent is a methane. A methane. Now, we are saying a substituent is supposed to be an alkane with 1 hydrogen atom less. For alkanes, the substituents are called alkyls. When you go to Alcènes, the substituent also becomes Alcyles. Then when you go to Alcyles, it becomes Alcyles also. It's 1 hydrogen, everything is the same. It's just 1 hydrogen atom less, 1 hydrogen atom less, 1 hydrogen atom less. That's how it's built. So what I'm teaching for alkanes here applies for the 3. The first 3, alkanes, alcyles, and alkyls. It's the same thing. It's the same principle, but with just a bit of addition on certain principles. Yeah. So the first one we are saying, we start with the first name, then we go to the last name. Now our first name, like I said, will always be the position at which the substituent is found at. Then the name of the substituent, then we're going to have la prefix. Then at the end, we're going to have, what's this? A suffix. Now you see what I did here was this is what the formula states. The formula states that we are supposed to have a prefix. Now this prefix here shows that we have got 4 carbon atoms, and this suffix here shows that we have an alkane. That's the function we are looking at. Now in this case, we have 2 vowels. In organic chemistry, when you have 2 vowels colliding, you supprime un. You forget about the other and write 1. You cannot write butane with double A. No, you write it with one A. This here was just to show you how the formula works. So this part here is the first name, the position of the substituent, and the name of the substituent is the first name. The last name is made up of 3 parts. The first part is called the prefix. The second part is what you call la chaîne principale. Now we said la chaîne principale. C'est la même chose avec la prefix. The prefix and the la chaîne principale, they mean the same thing. Now the suffix is what now determines what we are studying. Is it an aldehyde? Is it an alcohol? Is it carboxylic acid? Is it an ester? Like the suffix defines what we are looking at. So for now, is there any question? Because this here, what we've done here, is what we are going to be doing for all the compounds that are going to follow. First thing, we're going to look at the chaîne principale. Later, we are going to look at what substituents are we having there, and at what position are we having that substituent. Then the last one, which is also at position point number 3, is which route are we going to take? Is it the route from Cité, or bien is it the route from Medina to reach Carrefour? The idea is still the same, but we are going to now change it because we're going to be looking at compounds that are a bit complex, and this one here, the 2-methyl-butane. So far, are there any questions? Are there any questions? Another point I'm going to add before I allow a question is, this molecule here can be named either from this position, so 1, 2, 3. We're going to name it as well. So this is going to be 1, 2, 3, and this is 1, 2, 3. So we're saying the shortest distance possible. We have 3 and we have 3. It's like it's the same thing. So we're going to say, okay, we're going to start from this side. So it's going to be 1, 2, 3. So at position number 3 changes here. Now becomes position number 3. You're going to have 3. Now, what's the name of the substituent? The substituent here is a methane with 1 hydrogen atom less. Now, the substituent becomes a methyl. So it becomes 3-methyl. What's the prefix? The prefix is going to be 1, 2, 3, 4, 5. It's going to be penta. Penta. Then what's the suffix? The suffix is alkane. It's going to be A-N-E. So, like I said, if you have got 2 vowels here, you supprime A or biasa, then it now becomes one general name. It now becomes at position number 3, we have a methyl, and la chaîne principale is made up of 5 carbon atoms. So it now becomes a pent with a function N. So it's going to become at position number 3, 3-methyl pentane. Is there any questions?
Yeah, I'm a little bit behind on how the methyl is coming about. Is it always that the substituent should be a methyl?
No. So it's not always that the substituent is supposed to be a methyl. So I'll give examples here. I'll just give like 3. So at least we are on the same page. So I'll start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to put 1 here. We're going to put 1 there. We're going to put another one. Okay, here. We're going to put another one there. So that we kill 1 bird with 3 stones, eh? Yeah, it's important. So the first one, second example. 1, 2, 3, 4, 5. And no, let me not use methyl cambidium. So what's happening here? Okay. We can start naming these compounds, right? So the first rule we are saying, are you guys seeing?
Yes.
Okay, alhamdulillah. So rule number 1 is we are going to first look at la chaîne principale. La chaîne principale is the one that contains the highest number of carbon atoms. Now, in this case, I know it looks confusing, but please take your time. When you're doing nomenclature is the simplest part in organic chemistry. Take your time, count the number of carbon atoms. Don't rush and say, no, this is no. You might find that you didn't count properly. So we're going to start. We start in all positions, right? We'll start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11, right? For this zigzag across. So we'll start from here, foot. We'll say 1, 2, 3, 4, 5. Is 1, 2, 3, 4, 5. No, this was not going to be the chain principal. It's short. Foot is 1, 2, 3, 4, 5, 6, 7. 7, okay, 7. It's promising. So to start foot, you can either start from this side or this side, right? So 1, 2, 3, 4, 5, 6, 7, 8. 8, okay. This is 7, this is 8. So this is also giving us hope. So we can start foot to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Then we can really start doing a different foot this. That means shows though. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the other one is 1, 2, 3, 4. So you find out that the longest continuous chain in this case is this thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why? It's the one that contains the highest number of carbon atoms. Rule number 1, chaîne principale. Rule number 1 is la chaîne principale. Then we go now to substituents. So substituents, we have a lot of substituents. Who was that? Was it Musonda something? Is one that asked this question. Right? So we are going to now look at different substituents. It's not only methane, methyl. There are a lot. Even as far as 20, you can also have 20 is called icosa. So now if you have, now it's not possible that you're going to have, but in cases where you might have an alkyl group of 20 carbon atoms, it's not going to be called icosa. It's going to be called icosail, like this. So this shows that you have 20 carbon atoms for this alkyl group, but no one will give you such a thing. 20, it's too much. So it's called icosail. So now the question was, is it that it's only methyl? No, there are a lot. So we are saying this is a chain principal. Depth, this is a chain principal. So the nomenclature states that we are supposed to look for the substituents. Now the substituent we're going to have here, there are a lot. I'm seeing there's this one here. I'm seeing this one here. I'm seeing this one here, 1. There's another one here, 2. There's another one here, 3. Yeah, but let me cancel this one, guys. I don't want to confuse you. Because
but this example is, I think, is.
I'm speaking for someone here.
One thing is true. Some of us are going to get confused.
Exactly. You see what I'm saying? You see what I'm saying? So please let me, if I say 1, because it will bring problems. Yes, like this would be better. Let me even remove this one. Let me remove this one. Because apanika 2,2 die. We know not die. I will come to that one later. So for now, I just want to answer this question for Musonda that says, is it always that you're going to have methyl? No, it's not always methyl. It can change. So in this case, we are saying this is the chain principal with how many carbon atoms? 12. So we're saying 12 carbon atoms. 12 carbon atoms. This is the chain principal. Now a 12 carbon atom compound is called what? We come back to this. Can you guys see the screen I'm sharing? The one we're looking at first.
Yes.
So it's called what?
Yes.
A 12 carbon atom is called what? 12. Doda. Exactly. So now we go back. So where is it? Where is this? So sharing. So we are saying a 12 non-canisa is called what? Do deca. No, dodeca. This is what? If you guys are following. This is what? This is the number of carbon atoms that we have, and this is the prefix. The prefix. That's what you guys understanding even to explain it. I don't want to situation of that. Correct. So this is the prefix. So we are saying the prefix and the chain principale, they are one and the same thing. The prefix and the chain principale are one and the same thing. So the suffix will be what? The suffix will be alkane because ane because we are dealing with alkane. So suffix. The suffix. The suffix will be what? ane. So we use a different color. Then we are saying, okay, automatically this one is going to be called the last name. We can even go as far as just giving it the last name. Like I'm attacking the question from behind, from front. It's the same thing. So we're going to call this last name will be do, de, ka. Suffix ane. Now we're saying two vowels do not appear at the same time, so we cancel. It now becomes do, de. That's the last name. Now we're looking for the first name. For the first name, we are looking now for the first name. The first name now will be, so this part right, first name, first name. So the first name will be, okay, we are saying we have got two substituents here. We have two substituents. Now my question will be, which one is the shortest route to the nearest substituent? Which one is the shortest route? Is it this one here? Because you have 1, 2, 3. You have 1, 2, 3 at position number 3. And you also have 1, 2, 3, 4, 5. Which one is the shortest route to the substituent, to any substituent, either this route or this route? Which one is the shortest? My question is just simple logic. The shortest, which one is it? Is it this side, this one? 1, 2, 3. Position number 3. Or 1, 2, 3, 4, 5. Position number 5. Which one is it? The shortest route. Shortest route.
The first one.
Which one is the first one? Position number 3 or position number 5?
1, 2, 3. Position number 3.
Exactly. So position number 3 is the shortest route. In other words, or maybe when we are what I'm trying to say about the shortest route is the one with the smallest number. When you start doing to my compound, you'll be seeing the one with the smallest number, in other ways, is the shortest route. But when we are naming them, there's another rule now that comes in now. Because Muson does ask this question, there's another that is coming. So now we are on rule number 4. Rule number 4 states that whenever you have two substituents, you are also supposed to take into consideration their order in the alphabet. So rule number 4 states that when we are here, we are looking at the position 9. We're at the position now of the substituent. Now rule number 4, these rules, please, they will be increasing day by day. So every time you learn a new rule per occur. They'll be increasing slowly but sure. A bit, some of you will be confused, but it's the same thing. So position number 4, rule number 4 states that when you have got two substituents are also known as alkanes with one hydrogen atom less, aka alkyls. Something like this. Eh? Some of you might want formulas for words. It's written like this. This is how it's written. Eh? Alkyl. So we are going to take into consideration their position in the alphabet. Now we are saying this one here is a methane with one hydrogen atom less, and this one here, you change in a one. You know this one you're counting it in the chain, so the chain you're counting it here. You're also counting that. Now this one here has got two. There's one here and there's another one there. Now you'll be like, two. What is it called? We'll go back to our table and say, okay, for two, what are they called? For two, it's called F. It's called F. So we are going to change now because we are looking at an alkane with one hydrogen atom less. We are going to call it a what? We're going to call it what? We're going to call it what? This part.
Methyl.
Ethyl. We're going to call it ethyl. It's ethane with one hydrogen atom less, minus one hydrogen. It becomes a
Ethyl.
ethyl, guys. Ethyl. Nomenclature is not hard. It's the simplest. Ethyl. Then we have another one here. It is a methane. It's a methane. A methane with this line means one hydrogen atom less. It's going to be called methyl. Now, yeah. Rule number 4 states that we are supposed to look at its position in the alphabet. This one is a simple SP1, special paper 1. Which one comes first in the alphabet? Ethyl, methyl. Special paper 1. Which one comes first?
Comes first.
Exactly.
Ethyl.
E comes first. E comes first. Now, if we add propyl, okay, for example, I'll add propyl later on. If you add propyl, which one comes first? Is it E? Is it M? So the first one automatically becomes E. Now, which one comes first between the meth and the prop? M. Which one comes first between M and P? M or P? Which one comes first?
M.
Exactly. M comes first, so it's going to be M, then P. So in this case, our compound now, the name of this compound will be, this is the first name, this is the first name. This is the first name. We said the formula is the first name, what's happening? Anyway, the first name, let me come here. So it's the first name plus the last name. So we are saying the first name is going to be the position of the alkyl groups. In this case, what's the position of the alkyl group? The position what we have here, we have position number 3 and position number 5. Now we are going to the numbers. No, for the numbers you don't arrange them in ascending order, descending order. No, the numbers I just show you. I just there to show you the position. What we are interested in is the function or bien the alkyl group that we have. Please take note, the position of the numbers have nothing to do with ascending, descending. No, I can have 3, 5, 1 for as long as that's the alphabetical order. I can have, like this one, you see, this one is going to have 5, so let me write it. So we're saying this is ethyl at position number 5. This one is at position number 2. So position number 2. So when we're naming, oh sorry, number 3. So position number 3. So when we're naming it, it's going to be We're saying the longest chain is this one. That's the longest chain. And the shortest possible substituent that we're going to find in this chain is this one here, the methyl. But we're also going to take note that there's rule number 4. Rule number 4 says that we are supposed to take into consideration their alphabetical alignment. So E comes first. Then we have the M later on. Now, in this case, E is found at position number 5. So it's going to be 5, ethyl, comma, 3, methyl, do. So this part I, first name I, then last name. Guys, I have class foot at 14, so excuse me for these errors. I am very exhausted. So this is the name. Now, in organic chemistry, don't put comma here. The reason why I'm showing you these steps is because I want it to be built in your minds whenever you are naming these compounds. I want it to be built in your minds that it's always the first name and the last name. Please, these examples I'm using are not conventional examples. They are examples just to make you understand what's happening. When you go to school, when you're explaining for your friend, it shouldn't be that you're going to also tell them at first name, last name. The reason why I'm doing this is just to help you understand what's happening. Because another one might have their own initials. And I can also come in with DM. I can say, okay, D will be the first and M will be the last. So I'll be calling the D the position and the ethyl shan, and the M will be the normal principal shape. Anything that you come up with, for as long as it makes you understand, please feel free. This is just a way that I have thought of that is going to help you understand what I'm talking about. Yeah. So this part here, I'll even highlight it, is the first name, what we're calling the first name. And this part here, Kontanshoko, is what we are calling the last name. So this compound now will be called 5-ethyl-3-methyl-dodecane. So you are done with this compound. You are done. Point. Any questions?
Question.
Yes.
Question, boss.
Where are we starting to number?
Where are we starting? No, please take note.
Which route are we using?
Please take note. I'll repeat it again. I'll repeat it again. So the thing is, we're starting from this side to count. That's what I said. The numbers here, numbers have nothing to do at we're naming a compound. There's no rule. There's no rule. Please take note. There is no rule that states that you're supposed to have numbers in ascending order, because that's where the question is coming from. There's no rule that says that you're supposed to have numbers in ascending order and numbers in descending order. No. The only rule that you have is that these here, let me even highlight them here. Red. No, I'm saying green. Okay. Green.
Let me just clarify the question.
No, I'm coming to you. I'm coming. These functions, these alkyl groups are what determine the way the numbers will be arranged. There's nothing like, no, we are supposed to say 3, 5, no. Then, now, the question is, where are we starting from? We are saying, rule number 3 states that we are supposed to look for the position of the substituent that is closest. Shortcut, the same example I use Yakari for Shanshan. Same example I use Yakari for. So we are saying, okay, same example Yakari for same example. So the example that I gave was we are looking at which one is the shortest route? Is it moving from this position to this position, or from here to this in this? Are we moving? Okay, in other words, are we moving left to right or right to left? Now the answer is we are moving from this position here. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. Why? Why? Because when you look at the position of this substituent here, because this one is a substituent, this one here. Where is my pen? This position here, this position here. This position here, eh? There's another position here. So we are saying, which one is the shortest position possible to the closest, to the closest, or in other words, the shortcut? Which one is the shortcut to the nearest substituent? So we have 1, 2, 3 at position number 3, and we have 1, 2, 3, 4, 5. We have 5 there. Now my question is, which one is the shortest? The shortest possible distance is 1, 2, 3 to this substituent. It's the shortest distance as compared to this one. Okay, if you want to move from this position to this substituent, it will take you like 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon atoms for you to get to this substituent. But with this one, you just move like 1, 2, 3 to get to this substituent. Now the question is, when you're looking for the position of the substituent, you just count and see which one is the closest. Like I said, which one is the shortcut? Which one is the shortcut? I'll use methyl because it's the easiest. So you count 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6 becomes la chaîne principale. This one becomes la chaîne principale. Then this part here becomes the substituent. So now my question is, Mr. Blessing? The question is you're asking, which one are we starting from? Which route are we using? The answer is, it is the shortest possible route, as the shortest route possible for us to reach this position. Now, which one is going to be short? Starting from this side, 1, 2, 3. Ou bien 1, 2, 3, 4. Which one is going to be the shortest route? Is it this one on my right or this one on my left?
All right, let me just clarify the question. I was asking that question because if we start counting from this possible shortest routes, like where the first constituent is at position 3. So if we start from this route, when we reach to ethyl, the ethyl group, it's having position 8. Now why are we writing 5? So I was is it that every constituent has
sorry, yeah, you have a point. You have a point. No. Yeah. Thank you very much. Thank you very much. Sorry. Yeah, but guys, Nina Kamaisha. I'm supposed to prepare for Chimie General. So yeah, thank you very much for that point. Yeah. Sorry. So he has thank you. He has a clarity, a very good one actually. Look, when you're counting the number of carbon atoms, if you start from this side, that's the route you take. So this one here is not supposed to be 5, but supposed to be 8, because we are starting from this side. You don't take 2 routes at the same time, you just take 1. Thank you very much, Mr. Blessing. So this is going to be 1, 2, 3 at position number 3. Then you have 4, 5, 6, 7, position number 8, not 5, 8. So it will be 8. Sorry. Yeah, it will be 8 ethyl 3 methyl dodecane. Sorry, yeah. Is it clear? It's clear now, eh? Yeah.
Yes, it's clear.
Alhamdulillah. So we go to the last example. No, I think for now example is Kwapwa. Are there any questions?
No.
There are no questions. Should we do this last example or
No.
fine. I'm also tired.
Yes.
Yes, please. Yes, please. So,
On the third slide.
You have a question?
Yes.
What's the question?
On the third slide.
Which one?
Yes, and then no, the previous one.
This one?
Yes. From what Blessings was asking and the clarification you made.
Yeah.
So then, is it that the first substituent that you should follow is the one with the least number of carbons? Like if it the way we followed the
like this one.
Followed counting from methyl.
This is the root. Okay, let me use this simple. Let me answer this question in this way. Like the idea is you have two roots. You have got root number 1 and root number 2. Now, for you to get to a position, to a place, you can never go to the place with using two roots at the same time. You see. So if you start from this side, it means you count everything from every carbon atom that you count will follow this route that you used. You are never supposed to. This is a good clarity, Mr. Blessing. Thank you very much. This is a good clarity because when you're starting to count, you are supposed to count from where the substituent has the lowest index. Now, in this case, the lowest index is number 3. Now, you're not supposed to count in both directions. There is no way you would be going to carry 4 using two directions. No way. It can't happen. So if you're starting from this side, you'll be like 1, 2, 3, 4, 5, 6, 7. What's happening? 1, 2, 3, 4, 5, 6, 7, 8. Number 8. That's the route you're supposed to take. Then take, for instance, we assume, this is just an example. I just want to clarify a point for the one asking. So take, for instance, now, it was the other way around. If we start counting from this side, it's still going to be 1, 2, 3, 4, 5. It's now going to have position number 5. Then 5, 6, 7, 8, 9, 10. So number 10 here. So you see what I'm saying, So you see what I'm saying? So when you're counting, you follow through, you go in that direction. If you're counting from your right to your left, you follow through that direction. From your left to your right, that's the direction. This is the direction. From your left to your right, and from your right to your left, this is the direction. Now, this direction is not imposed, right? It depends on which substituent has the lowest index. Now, in this case, you can look at this one has got 5 and this one has a 10. The lowest index here is 3. So automatically the 3 becomes our direction we're going to take for this compound. So this marks the end of the first part of the alkane nomenclature. So this is alkane. Nomenclature. Then the next time we come, we are going to do, it's just examples and some rules, addition of some rules, to Alcines. So you guys, those that are doing Chimie General, so thank you very much and have a blessed day. So if there are any questions, please, you can inbox me. If you have any queries, any clarifications, if everything is clear, alhamdulillah.